Okay, for part 2 of the video, which is part B of the question, and again, this is question 2005B, question 4. Okay, for the function g defined in part B or part A, and remember g is the function of the integral from -4 to x of f of t dt. Let's just double check that I got that right. Yes, that is correct. Okay, good. Find each point of inflection of the graph of g. Okay, think about this conceptually. Look at our ladder of derivatives again. Okay, if f is here, g is there because it's the integral of f, right? F then is equal to g prime, and f double prime is equal, f prime is equal to g double prime. Okay, so here's our ladder of derivatives. Now, if we're trying to find a point of inflection of g, that happens, inflection points happen when the second derivative changes signs. Okay, now this is all part of your explanation, so we're actually answering it here before we actually find, quote, the answer. Inflection points happen when g double prime changes signs. Okay, now g double prime is f prime. So what we need to look at is the slope of the function of f. Okay, look in this region. The slope is positive, so f prime is greater than 0 here, because you see the slope of the line's positive. Here f prime is also 0. F prime of x is greater than 0, that's positive. Over here, f prime is less than 0 because the slope of this line here is negative. And look what we have, a change in sign in the first derivative, right here to right here. Cool. Since g double prime changes signs at x equals 1, g has an inflection point at x equals 1. There's your explanation. For question C, they're changing the integral on us a little bit. Okay, so now h of x is going to be this integral. Now let's talk about what this means, okay? This is the integral from x, some value we don't know that's going to change on us, to 3. All right, so let me draw a line down here at 3. Our integral is going to stop regardless right here. The x value can change. We've got to find all the values of x that will cause this integral to be 0. So what they're saying is, what values of x will make the signed area from x to 3 equal to 0? Well, I see a couple of them actually. Let's talk about right here. Suppose x is 2. Is the signed area from 2 to 3 going to be 0? No, it's going to be negative because of that area. But from 1 to 3, look what we have. We have a positive area triangle and a negative area triangle, and they're the same size. So this integral is going to be equal to 0, won't it? All right, so x at x equals 1, this integral is going to be equal to 0. Now, do you see any place else where that happens? The answer is yes. Another place is going to be right here. If you take the integral from -1 all the way to 3, we're going to add up this negative area, this positive area. These are the same size, so they're going to balance each other out. And we already know that this area and this area will balance each other out too. So at x equals 1 and x equals -1, those are going to be our two areas, or our two values of x. And the reasoning is because the areas will balance each other out. Okay, so there's part C for you. Okay, this question here, part D, is the part that separates those who get the 4s from those who get the 5s, because this is a pretty difficult question. Okay, we're trying to find the intervals of x on which this integral is decreasing. Okay, probably, you can think about it as looking at areas, but it's actually easier to think about it in terms of derivatives. Think about this. H prime of x is equal to negative f of x. Okay, now how did I get that negative? Now, let me go through the analysis that we did in class a couple days ago. Okay, the integral from x to 3 of f of t dt is equal to some function whose derivative is equal to f evaluated at 3 minus that same function evaluated at x. Okay? If I want to take the derivative of this integral, I can do that. The derivative of capital F of 3 minus capital F of x is easy. It's 0 minus little f of x. Why the 0, you ask? If you take a constant and plug it into a function, you're going to get a constant. This term right here doesn't ever change. If it doesn't ever change, then its rate of change with respect to x is equal to 0. Derivative of a constant equals 0. This term right here does have a derivative because it's a function, right? And the derivative of capital F is just the little f it came from. The little f it came over here. Little f it came from. There's a negative in front, so there's the derivative. So this is equal to negative f of x. We've got to figure out when f is positive, because that will tell us when the derivative of h is negative, right? So to find out when h prime of x is less than 0, let's just figure out when f of x is greater than 0, because the negative will make it, negative in front will make this term negative. Cool. So where's f of x positive? From here to here. And so x has to be in the interval from 0 to 2. And actually it's an open interval. We don't count 0 as being positive or negative, so it's an open interval. And that's how you do that question. And here's the work you would show with that. So that's actually, it's a very difficult conceptual question, but it's very easy to show if you understand the concept. Cool. And there you go, question 2005B, question 4.